Today, I am going to explain problem 10 of the GUTS round of the Hmmt of 2023. The number 316990099009901 is equal to 32016000000000001 divided by 101 is the product of two distinct prime numbers. Compute the smaller of these two primes. So basically what we want to do here is we want to break this number into like two prime numbers, one small and one big, and we want to find the value of that small prime number. So let's just do this. So this number, we can just like break it down into 3, 2, there's like 15 zeros here, 1, 13, 14, 15. So, plus 16. Oh, wow. I'm just gonna do this. But yeah, you get the idea. So, there are like, so we can just like expand it out into like three numbers being added together. 16, I shouldn't write it like this, but there's 12 zeros in the 16. 12. Plus 1. So right here, we immediately notice something with these two big numbers. They can all be factored into a power of 2000. So let's do that. This number right here, this absurdly big number, this is equal to 2000 to the power of 5 plus 2000 to the power of 4, because it's this number right here, and you still add that 1. To make this like a lot easier to solve, we use substitution, so we let x be equal to 2000. So now our equation is going to be x to the power of 5 plus x to the power of 4 plus 1. So we are currently stuck at this roadblock. In this problem, in this video, we will actually explain two ways on how to break this up. The first way is like by doing something like this. X to the 5. First you complete the sequence, plus x to the power 4, plus x cubed, plus x squared, plus x plus 1. Now, we have our initial equation, x to the power 5 plus x to the power 4 plus x to the power of 1. What we added is x cubed plus x squared plus x. So we need to subtract that. And from all of this, we can just like take out a common factor. With these first three terms, we can take out a factor of x cubed. So it's now x cubed times x squared plus x plus 1. And then you just add plus x squared plus x plus 1. And now you might take out the x in this equation. So x squared plus x, plus 1. So now we can remove the brackets and take out the common factor of x squared plus x plus 1. So this is now equal to x squared plus x plus 1. On the in the other parentheses, we have x cubed plus 1 from this, and you subtract an x. So now we essentially have two numbers being multiplied together, most likely prime numbers. Now, all we have to do is figure out the smallest prime number here and just calculate that value. Realize earlier that we let x be equal to 2000. We realized that x squared plus x plus 1 is in fact the smaller value. So therefore, we could just substitute it back in. Let's just do it up here because I'm running out of space. So it's now 2,000 squared plus 2,000 plus 1. We can just solve this. This is 4 million, I think. Plus 2,000 and 1, since that's 2,000 plus 1. This is just 4 million and 2,001. So this is the first way of actually finding out what this is. This second way is much more abnormal. So basically, in this way, like usually we want to increase the powers, but now we want to decrease the powers. We can do that one way by multiplying this by, so x to the power 5 plus x to the power 4 plus 1. That is our nice little equation. You multiply it by x minus 1. Oh, and it's fine. X minus 1. So there. Now we can just multiply this out. This is x to the power 6 minus x to the power 5 plus x to the power 5. These cancel. Subtract x to the power 4. Add x. And subtract the 1. All divided by x minus 1. After some rearranging here, we can rearrange this from down there as x to the power of 6 minus 1 to the power of 6, because 1 to the power of anything is still 1, minus x to the power of 4 plus x over x minus 1. This is an a plus b times a minus b equation, so this is now just equal to x cubed plus 1 cubed times x cubed minus 1 cubed, because x cubed squared is just x to the power of 6. And now here we can take out the factor of x, which is now, so this is now x cubed plus 1 cubed. Well, no, it's minus 1 since there's a negative there. But we do the cube thing to make it more sense. So here we see that we do the cubed so we can take out a factor. Here we see that both these terms have a factor of x cubed minus 1 cubed. So let's take that out. So this is now just equal to x cubed minus 1 cubed times, well, this is just x cubed plus 1 cubed, but we don't need that cubed anymore. Subtract the x and divide by x minus 1. According to algebraic formulas, we can further break this down. X cubed minus 1 cubed, that's x minus 1 times x squared plus, oh, sorry, I forgot to mention, no, you're not supposed to write equals here because it's not equal, but it's x minus 1 times x squared plus x plus 1. So now we see that this equation is equal to x minus 1 times x squared plus x plus 1 times x cubed plus 1 minus x. Divide all that by x minus 1, but we don't need that since these two cancel out. Now, once again, we have our smaller number, and by implementing again that x is 2,000, we get that x squared plus x plus 1 is equal to 2,000 squared plus 2,000. 2,000. Come on, 2,000 plus 1, which is equal to 4 million and 2,001. So we have our final answer right here again. And since we were given earlier that they have to be prime, like if you divide this by 101, it does not output a whole number, so therefore we know that this is prime and this is our only answer.